Greetings, friends. Welcome to the Storytelling Podcast with your host and celestial navigator, Gemini Brett. Today is August 14th, 2026. If you're into that whole Gregorian trip, and I'm here to speak about an amazing thing that's happening today. It happens about every 19 months, every 584 days. And this is Venus at greatest elongation as an evening star. Now, some of the astrological codes might suggest this is a particularly interesting one. We will explore that. But the thing I'm most interested in sharing with you, besides what is Venus elongation, is why, on one level, this describes the time when Venus is most visible, but on another, that might actually not be true. So we're going to look today also, and get your glasses on, into celestial and terrestrial factors of Venusian visibility. In the sense of starry visibility in general, I'd suggest the master class is with Mercury, but Venus is the way in. Venus the beautiful, Venus the bright, Venus, who I imagine next to the sun and the moon, next to the celestial lights, is the brightest being in our sky. And then Jupiter. Well, Jupiter's gigantic, but so much further away than Venus, right? So Venus's proximity as our celestial neighbor, along with Venus's albedo, like the color and composition of the planet, creates this brightest being in the heavens next to the sun and the moon. And there are times when Venus is brighter than others. There are times when Venus cannot be seen at all. There are times when Venus can be most seen. And again, if we learn these things, if we study with Venus, then we learn more about the visibility of Mercury, which in a way is the master class, because until we learn some of these more advanced sacred astronomical contributions, terrestrially and celestially, to planetary visibility, we can't really understand why Mercury is incredibly visible sometimes and not at all visible at times when the chart might predict Mercury would be. So these are things I'm excited to show you today. I love teaching the astronomy of the thing. Why? Because mine is the school of Earth astrology, where we know astrology is so much more than some symbolic language alone. We know astrology to be the poetic breath of nature. And therefore, when we re-nature our astrology by reconnecting to the mysteries of the living sky, we will remember the roots of the rules and the proofs of the astrological equations we use. This is not me in any way suggesting that we should approach our sacred art in some mathematically cold way, but just to say that there is something about aligning ourselves with the measurable side of the heavenly happenings. That's astronomy. This offers more of an opportunity to experience and to express the immeasurable, the correspondences. So Venus at maximum elongation, there's a correspondence here. There's something that we will feel. There's a contribution to our energetic experience as earthlings, right? And I'll say today with Venus in Libra, reflecting Leo light, there's something about creative collaboration, if you will. And I hope that Venus herself will shine some light on this presentation. And also, most importantly, this, along with almost everything I do, I hope will serve as an invitation, a reminder for you to get away from these small screens, though I'm very glad you're here, and head out to the big screen, the living sky, and to connect. So before we even dive into the pretty pictures that I've created for our learning together, let's just remember that this time of Venus at greatest elongation invites us to head outside and experience the bright and amazing and beautiful Venus as an evening star in the sunset west. Well, I'm excited to show you why this will be even more incredible for those of you who live in the southern hemisphere, and especially around 20 degrees south latitude. What? Why? Because there are astrological contributions, terrestrially, celestially, great contributions to the planetary visibility. All right, so let's head forward in this. And we see an image I imagine you have seen before of the great star or five-petaled rose described by Earth with Venus and our mutual dance about the sun, or from Earth's point of view, the dance of Venus and sun through our zodiac. And we're not going to spend too much time with this, with the five petals of the rose today, although we're in very interesting times in that consideration. Besides, and maybe I'll have some time to play with this at the end, to say that there are 5 different shapes that Venus describes in our sky over an 8-year period. And that those 5 shapes themselves very slowly change as the Venus star slowly retrogrades through Earth's zodiac. Now, that might sound like an entirely foreign language. If it doesn't, you might say, well, these are things that I've learned, and wait, it seems like maybe there are some nuances I have yet to. And I'm excited to share more of those beautiful expressions along the way, probably some other time. Today, again, I'm going to focus on Venus at greatest elongation. What does that mean? How can we tell in the chart? How does that show up in the sky? How does that show up when we have our feet on the ground? How would it show up if we're looking from space? By the way, I'm presenting this live. Some of you will be tuning in from a time that I currently perceive to be the future. Glad you're here. Please give the channel a like, hit the subscribe button, come around. And if you're watching this on Instagram, I'm so glad you're here, but you'll also be looking at a very tiny screen on the slide. So you might want to come over to my YouTube space. You can find my live teachings there always quickly through typing GeminiBrett.com/streams into your machine. Why don't I throw that on the screen real quick? Gemini Brett with 2 T's, Gemini T/streams. It looks something like that, right? So if you'd like to see this full screen, head on over to that place. All right. Let's head out to space. And we can do so, or at least simulate this, thanks to a really wonderful software called Solar System Scope, which you can play with at solarsystemscope.com. So before we take a peek at some of the principal phases of the Venus synodic cycle, meaning the cycle of Venus in her meetings with the sun. Of course, from Earth's point of view, we are Earthlings after all. Well, I shouldn't assume anything about you. It's important that we create a structure that will help us describe heavenly placements and our experience of them here on Earth. And so I'm going to do this using the most elegant and beautiful earthstronomical structure called the tropical zodiac. You'll see as I continue this animation of this heliocentric or sun-centered model of our solar system, thanks to solarsystemscope.com, that the north pole of the Earth is leaning down towards the bottom of your screen. There's another clue to that. If you look at the date at the bottom of the screen here, you'll see that this is June 21st, 2026. So the summer solstice, right? Wrong if you live in Peru. So I would prefer, while acting locally, to think and speak globally rather than calling this summer solstice here June 21st. Of course, that's the experience in the northern hemisphere, the longest day, the shortest night. But of course, the opposite truth down under. So folks on June 21st-ish in Melbourne, Australia are experiencing winter solstice, right? So it's a tale of two hemispheres. And the tropical zodiac is not a seasonal thing, or else it wouldn't work in the southern hemisphere. And it does. And it would have to actually be expressed in a very different way in London than Honolulu, because these are very different experiences of the seasons, even both locations in the northern hemisphere, but one much further from the equator, one in the tropics. Yes. No, as I've explored this challenge of, well, the tropical zodiac is not constellational, right? The tropical signs do not align to the constellations like you'd think they would, and they don't, like they did 2,000 years ago. And because the constellations that embrace the ecliptic plane, the path of the sun, and for the most part that of the planets, right, the zodiac constellations, because they are not equally 30 degrees in size, you could never map a zodiac of equal 30-degree signs to those constellations. These are arguments that you often hear from the rationalists as their kind of principal claim and their attempt to prove astrology fake. They are arguments you'll hear from those who prefer a more star-based zodiac, be it sidereal, one of the many, many sidereal zodiacs, or constellational, something that somehow oddly has become, I don't know if popular, but around these days, and the whole 13th sign thing you've heard me speak about before. If you haven't, you can search Gemini Brett, and no on Prop 13 will probably get you there. Anyway, people will say that the tropical zodiac is just this symbolic thing because it's not aligned to the constellations like it was in the Hellenistic era. It's not aligned to the constellations today like it was yesterday, though very little difference. And many will say, no, it's a seasonal thing. But again, we have this issue of the two hemispheres, right? What I've found in exploring, well, what is the tropical zodiac? I'm very interested in asking that question because I see that it works, but why? If it's not constellational or seasonal, what I've found is that, like so many sacred systems of ancient wisdom traditions, the tropical zodiac is directionally aligned. It is aligned to Gaia's spine, to the sword of our stone, to the world tree, to Earth's rotational axis, which defines the cardinal directions and therefore the cardinal cusps of the tropical zodiac, which is Earth's zodiac. So the North Pole of Earth is leaning always towards that part of the sun's path that we call 0 degrees Cancer, at least in the tropical zodiac. And it's why that degree of the sun's path is above Earth's Tropic of Cancer. Now, this is meant to be a video about elongation and about the visibility of Venus. And by the way, these rules again will also apply to Mercury, who's in a sense a more intense study. But somewhat of what I'm going to share with you in regards to both celestial and terrestrial factors that contribute to Venusian visibility. These are tropical factors. We're going to get into something that the ancients called the straight and the crooked signs, for example, and how those behave in a different way from London as they do in Hawaii or Peru. Um, Welcome, Wade Caves. Wonderful to see you here. So again, we're looking at a heliocentric model at the June solstice, and I'd rather call that June solstice than summer solstice because it's the winter solstice in Bolivia, yes. But I'd even rather call this the Cancer solstice. It's the time when, because Earth in our orbital path arranges for our northern axis to be leaning towards the sun, and that's the sun shining directly above Earth's Tropic of Cancer, the sun ingressing tropical Cancer. But think of this, it's Earth's North Pole leaning towards the sun in that one moment, right? So I'd rather call this the Northstice. It doesn't sound quite as poetic as on the other side of the year when it's the Earth's South Pole leaning towards the sun, summer solstice for the southern hemisphere, winter solstice for the northern hemisphere, right? The Southstice. But I just like to use this language to help us remember that the tropical zodiac is directionally aligned. And I personally feel that it's not coming to us from out there, but rather that it emanates from the heart of Earth and heads out infinitely towards to the heavens. So we're going to do that in the slide here. I will say again, I have much gratitude for Solar System Scope. That's the heliocentric model that I'm using that we'll witness in many of these animations as we move forward. But you can't do this at Solar System Scope. Watch as the zodiac emanates from the heart of Earth. And maybe we'll do that again because buttons. All right, we'll use the clicker thing, right? So this is this image of the zodiac directionally aligned, emanating from the heart of Earth outward. Now we have a reference frame. Right now I can say, oh, that sun is right there at the cusp of the yellow air sign Gemini and the blue water sign Cancer. Again, tropical, right? So that this is that moment of the sun moving from Gemini into Cancer. Of course, it's the Earth that moves the sun through the signs. That's not true for Mercury, right? But it's actually, or for Venus or for Mars. But interestingly, as we'll really get to see in these animations, those planets moving through Earth signs have to do with two things. Have to do with their own movement about the sun, like Venus's orbit of the sun, and Earth's orbit of the sun. So you see more of that as we move forward. All right, and these things are necessary for us to set up the conditions of the celestial and terrestrial factors that contribute to planetary visibility. All right, so Venus here is in the sign of Leo. Now, Leo, I can just say, is the northwest sign. The cusp of tropical Gemini and Cancer is due north of Earth. The cusp of tropical Virgo and Libra is due west. And I'm talking about from the center of Earth. And therefore, the middle degrees of Leo, that's like northwest of Earth's center, the heart of our planet, the place where we all connect. So at this point, in the mutual dance about the sun between Venus and Earth, we have it so arranged that Venus is like northwest of our planet. The more you can experience and understand the tropical zodiac as a directional device, the more the astrology can speak to you and your experience here on Earth. All right, well, let's move forward in time just after we bring in this chart. I'll say that I'm creating these slides, of course, for my School of Earth Astrology. You can learn more about that at geminibrett.com. But I've recently assembled and updated a lot of these things for a course that I'm co-creating with Daniel Jamario for his Turning of the Ages Mystery School. Daniel, my first teacher and person I learned so much about the synodic cycles from. So we together are currently creating the synodic cycles course for the Turning of the Ages Mystery School, and you can find them online to hear more about that course. I think it will be slowly launching next month. And that's the Turning of the Ages Mystery School logo that you see up to the left of this chart, which comes from Astro Gold astrology software. As you can see, I've limited the display to only the so-called personal planets. You see the moon and Mercury, Venus, the sun, and Mars, because they're the only ones that I could fit on the screen from this view from outer space of our solar system. All right. And watching the heliocentric or sun-centered solar system moving as we watch the chart move, the geocentric chart, which in this case is oriented as I have the solar system on the other side, meaning north is down, Earth north is down. The chart is geocentric. That means Earth is at the center of the chart, and Earth's north pole is leaning towards the downward direction. We could set that up in any way, but when you have 0 Aries, tropical Aries on the left of the chart, that means it is east, and 0 tropical Aries is due east of Earth's center. And that means north is down. And that can be kind of confusing because, of course, most of us were shown the mariner's compass where north is to the top and east is to the right and that kind of thing. All right. So let's just compare the chart on the right to the solar system image on the left. See the moon in late degrees of Virgo. Well, if you look to the solar system over there, you'll see the moon just in kind of the late degrees of the green Earth sign. All right, that's Virgo, because again, the green Earth and the yellow air of Libra, they share that cusp that is due west of Earth center, and west is oriented, as we do in astrology, towards the right. Okay, we see Mercury in the blue, that's the water sign of Cancer. Venus in the red, it's the fire sign of Leo. We see Mars down into the left of Earth in the Earth sign of Taurus. Okay, well, this gets much more interesting when we let it move. So let's move through time. And just follow the moon. There's moon into Scorpio, you can see in the chart. If you look in the solar system view, the moon into the red of Sagittarius, now the green of Capricorn. It got to Earth's southern side. Now the moon's on the east side of Earth, from Pisces to Aries, like that. Well, let's look at Venus. Venus just moved into the sign of Virgo. And if you look at the date in the lower right, you'll see we're just going day by day. We're in July 22nd, 2026 here. All right. Venus about halfway through the sign of Virgo. And why did I stop here at this date? Because I want to speak a little bit about the surface experience on Earth, okay? The sun has just moved into Leo. See that in the chart on the right? And we can see that in the solar system view only because I directionally aligned a 12-sign zodiac. The center of the sun just moved from the blue waters of Cancer to the red fires of tropical Leo, okay? Well, that's a center of the earth truth. Fascinatingly, we measure astrology, at least in regards to planets in the signs, not from the surface of the earth where we live and breathe and can witness these heavenly happenings, but rather from Earth's center, that place where we are all connected, right? So when I show you the planets in the signs, or the way that the planets are related to one another, if you look at the chart on the right, this is generally speaking the time of Mercury square Mars. Well, notice if you looked from the sun, Mercury and Mars are kind of more opposite. Like that's an Earth thing, and it's the center of the Earth here, which is experiencing Venus and Mars in a square or 90-degree relationship, right? It's the center of Earth that's experiencing the Scorpio moon in a hexagon or a sextile relationship with Venus, okay? So signs are about the center, the below, the whole. But the houses, of course, that's a surface of Earth experience, yes? Like what is rising in the east for me right now is different than it is for Lori, who's beaming in from the east coast of the States. Or let me grab another name who's currently participating. Oh, I see Nick here, who's in Virginia, right? Thanks for being here, friends. So there's a center of the Earth experience, that's the planets and the signs, and then there's the surface of Earth experience, it's the planets in the houses. All right. Well, I've drawn this line, as you can see, from Earth to the sun and from the center of the Earth to the sun. But I'll just say that it's cutting through places on the Earth. I don't know if that's showing up on your screen, but like California, where I'm currently sitting, is one of them, where we've stopped on the animation that arrow is moving through. This is a time where the sun would be at the midheaven for Berkeley, California, where I currently sit, right? Because that side of the Earth is spinning through that time where it's facing the sun midday. But what about on the exact opposite side? It would be midnight, right? So I just darkened that side of the Earth, right? Earth is always half in the light and half in the darkness, day and night. Earth is spinning west to east, okay? So generally speaking, we're kind of looking down at the north of Earth, and that means that rotation, that daily motion of Earth in this animation is going to be counterclockwise, all right? And that means that folks here, maybe you just saw the arrow moved, they're just spinning out of the shadow, spinning out of the night and into the light, right? So that is the sunrise side of Earth. Well, I'm pointing to the place on Earth now that would be experiencing Mars rise. And that place on Earth is still in the shadow. So in other words, Mars is rising before the sun, right? As Earth is spinning, locations are experiencing Mars rise on the horizon, and then sometime later, the sun. Well, we know Gemini rises before Leo. So let's just point that out on the chart, because one of the things that we're going to be exploring here in visibility is morning star versus evening star. So if you haven't learned this yet, just a general rule to know is that planets in earlier signs than the sun, or earlier degrees of the same sign as the sun, are on the morning star side. So for example, in the chart here, Gemini Mars rises before the Leo sun. Cancer Mercury rises before the Leo sun, right? Whereas Venus here is on the evening star side, right? The Leo sun rises before Virgo Venus. So we don't see Venus rising because the sun is already up. But the Leo sun will set before Virgo Venus, meaning the sun sets and there's Venus on the evening star of the side. I bet you everybody watching this is already hip to morning star versus evening star. But if you're not, I think this is very essential for us to study important celestial and terrestrial factors of visibility, right? If I'm looking at a chart and I want to go see Venus, well, I better know if I'm waking up before the sun to head out to the east, or if I'm going to go to the west after sunset. And importantly, as we will describe more and more as we move forward here, Venus is only either going to be seen in the eastern sky before sunrise or in the western sky after sunset. I'll get back to that, okay? So the moon here, and this is always true for the waxing moons, The moon's also on the evening star side, right? Leo sets, then Virgo, then Libra, then Scorpio. So when the Leo sun sets, that Scorpio moon is going to be visible. It's an evening star. But when the Leo sun rises, the Scorpio moon will be down beneath the ground, right? Not a morning star. And as you can probably tell or already know, the differentiating degree would be exactly opposite the sun, right? So generally speaking, you can draw like a semicircle from the sun degree to the degree opposite. And if you move in the counterclockwise direction from the sun to that opposite degree, you're on the morning star side of the chart. Sorry, the evening star side of the chart is counterclockwise to the sun, like Virgo is counterclockwise to Leo, and then Libra, Scorpio, Sagittarius, Capricorn, until in this case we get to Aquarius with the sun in the first degree of Leo. But on the clockwise side from the sun, like Cancer is clockwise to Leo, right? Gemini even more so, Taurus even more so, Aries, that's going to be the morning star side. Okay, I think I'm spending too much time on this, but if it's not something you've learned yet, this is absolutely essential. All right, so let's look on the left now in our heliocentric from space view of this same moment at where on Earth Venus is currently setting. So you can see I'm just kind of drawing a perpendicular line from Earth, from Venus center to that side of Earth that's currently, as you can see, in the shadow, right? So these are people who have already spun through the sunset moment. Presently, that's where that other arrow is, right? They've already spun into the shadow. The sun has set. They've moved from day to night. And Venus is still in the sky for those in between those two, sides of the arrows on Earth, right? They're going to spin for a while still, and then Venus sets. This is going to be helpful to see when we put our feet on Earth. All right, but first let's move through time a little bit. Back to the orbital motion. Check out Venus here. She's in 23 Virgo if you look to the chart, but look to the solar system. You'll see these signs are moving with Earth, and there's Venus moving from Virgo into Libra. Now, some would say this is a homecoming for Venus, right? And I'm stopping here, which is the day I'm presenting this material, August 14th, 2026. Why? Because this is the time of Venus's maximum elongation or greatest elongation as an evening star. So what does that mean? Well, let me just put this away for a bit and we'll wrap. All right. Think about the moon. Let's say my face is the sun and you are the earth and this is the moon. Do we want to do it that way? Yeah, fine. So this would be new moon. Moon coming between the earth, who is you, and the sun, who is me, right? Well, then the moon's going to go back behind the earth. Like you can't see it anymore unless you turn around, and you can't because you're a camera. No offense. Right. But importantly, the moon can get to the opposite side of the earth, right? So can Mars. Right? Mars's orbital path is beyond Earth, so he can be back here behind the sun, and then Mars can go back on the other side of the Earth. Does that make sense? This cannot ever be true for Mercury or for Venus. They are the interior planets. The astronomers call it inferior, which just means below. I prefer interior and exterior to inferior and superior. But because these planets' orbital paths are interior to Earth's, they can only either come between Earth and the sun and then head out to the other side of the sun. Like both Mercury and Venus, they have two different types of conjunctions. They pass the Earth by, passing between the Earth and the sun. That's the retrograde, let's say Venus sun conjunction from Earth's point of view. And then later, Venus will go here, back behind the sun. It's still, from Earth's point of view, a Venus sun conjunction. They're aligned, but it's a very different kind of thing than this, right? So the retrograde Venus sun conjunction is the interior, or they say inferior conjunction of Venus, which does not mean lesser than, it means below. It's like she's below the realm of the sun, closest to Earth. That's a retrograde Venus, right? And then later in her cycle, about 9 months later, Venus goes back behind the sun, far from Earth, can't be seen. And that is direct Venus conjunct the sun from Earth's point of view. You dig? So, but Venus can never go to the other side of Earth, right? Like when the moon's on the other side of Earth from the sun, that's full moon, right? Moon fully reflecting sunlight back to earthly eyes. Venus can't get opposite the sun. The opposition, of course, of the moon facing the sun, other sides of Earth, opposite sides of Earth, right? Full moon. And of course, the further the moon gets from the sun, the greater the phase, right? We grow from that sliver smile of the young moon to the full O, and then shrink into the, Hecate's bow, the balsamic moon, before the moon and sun meet again. Well, Venus can never get, further than that from your point of view. See how this like angle works from your point of view? And Mercury can't even get that far because Mercury's path is closer to the sun, you see? The furthest Mercury can ever be from the sun in Earth's zodiac is like 28 degrees, and that's kind of rare. The furthest Venus can ever be is 48 degrees away. So in the Venus cycle, as an evening star, before the retrograde, before the interior retrograde Venus conjunction with the sun, Venus will get to this place where Earth is experiencing the maximum angular distance. It's obviously not here, right? Venus is conjunct the sun. The phase angle is 0 degrees, yes? Here, we're just seeing Venus kind of coming out of the bright beaming light of the sun. And then she shows up again, right? And then like she's slowly separating from the sun, and this angle is growing. You see how that works? And then there's a point where now it's starting to shrink. You see that? And now 0, right? Now conjunct again. Well, then on the morning star side, same kind of thing, very close to the sun, getting further and further and further away. And then that angle decreases as Venus heads back behind the sun. Do you dig that? See how that works? So this point in time, when Venus, from Earth's point of view, is furthest from the sun, and this is important. This is not Venus actually furthest from the sun. All orbits are elliptical. Like Venus has her close to the sun part and her far from the sun part. For Venus, she's actually the most circular orbit of all the planets, which makes sense. We associate Venus with harmony and beauty, and symmetry can contribute to the beauty of the thing. But when we see Venus at her greatest elongation, it's not Venus in her own orbital path as far distant from the sun. It's our experience of Venus's maximum distance from the sun. Does that make sense? I want to say hey to Ellie, who's here. Says Venus Day blessings. Looking forward to seeing her tonight. Yeah, it's Friday. It's Venus's day. We got pretty close to Friday the 13th. It's the 14th today, though. And 813 is a very beautiful numbers that help bring us into the sacred pentacle or rose shape that Venus and the sun describe in Earth's zodiac, and that's tales for another time. But Ellie, thanks for being here. And I just want to put that on the screen because Ellie, like me, is she, herring Venus, right? And it was like a good reminder in the moment for me to say, hey, you like might not be into me, speaking of Venus or any other planet in some kind of gendered way. And I get that. For me, it helps me create the experience of a more known or meaningful connection, right? That's like my limitation. Of course, not Venus's. I believe planets are beyond gender. But for me, it's like helpful to know Venus as this she queen, that's how I do. So I hope that language isn't offensive to you. And It is. I hope that explanation at least helps you understand where I'm coming from in that regard. Okay. Cool. So let's get back to the pretty pictures that I take a gazillion years to create. By the way, GeminiBrett.com/donate is a place where you can support the work. Buy me a cup of tea if you'd like. GeminiBrett.com in general is a place where you can support the work by buying a session. We can look at where you were born in the Venus cycle, how this elongation speaks to you personally. And you can learn about the constellations community at GeminiBrett.com too, where there's teachings like this every week. All right. So Venus at maximum elongation. Let's look to the chart and do the math. Zodiac math's tricky, right? It's like, how far is 8 from 22? Well, how far is 8 Libra from 22 Leo? That's our question here, right? If we add 8 degrees to 22 Leo, where the sun is in this moment, we get to Virgo. Does everybody agree? Because 30 degrees in a sign. So 22 plus 8 is 0. Like, what? And there's other ways you could do this, but stick with me. You already calculated this, I bet, right? So 8 degrees from the 22-degree Leo sun brings us to Virgo, 30 degrees of Virgo to get to Libra, right? So the sun here is 38 degrees from 0 Libra. 8 to get to Virgo, 30 degrees of Virgo. And now we need another 8 degrees from 0 Libra to get to Venus, right? So 8 plus 30 plus 8. In other words, 46 degrees, a little bit less. So in this particular cycle, the maximum elongation for Venus, 46 degrees away from the sun. Those of you who have studied your harmonics might know that as a semi-square, or it's half of a 90-degree square, or an octile. An eighth of the 360-degree zodiac is 45 degrees. And yeah, Venus's maximum elongation is 48 degrees, but again, that does not happen in every Venus cycle. By which I mean to say the Venus synodic cycle, meaning the cycle of Venus's dance with the sun in Earth's experience, in Earth's zodiac. And that's a period of about 584 days, 583.92 days, but who's counting? We are. It's about 19 months, 19 and a half months. It's in this realm, okay, where Venus has this dance coming in between Earth and the sun, going to the other side of the sun, and coming back in between Earth and sun again. It's about 19-month period, okay? And in that period, we're going to have Venus's greatest elongation as a morning star, and then her disappearance into the flames of the sun, and then her rebirth from those flames of the sun, and then the greatest elongation as an evening star before the retrograde period happens as Venus is passing us by. And we're going to watch at least the retrograde period here into the interior Venus sun or retrograde Venus sun conjunction, because that's going to help us understand more about the celestial and very importantly terrestrial contributions to Venus visibility. After we do that, we're going to come back to this date, to August 14th, 2026, and I'm going to show you why this particular greatest elongation of Venus is even more visible in the southern hemisphere than in the northern hemisphere, and why, I mean, it's kind of maxed out around 20 degrees south of the equator. So I think I cast a chart for Paraguay. Generally speaking, and this is like celestial factor, let's say something that we can see in the chart. Venus at the greatest elongation, the greatest phase angle from the sun is, let me say, obviously the most visible Venus, meaning the sun sets and we have the most time with Venus as an evening star. The sun sets, and now we have a full 46 degrees of setting zodiac before Venus sets, right? Well, here's the trip. 46 degrees of phase for Venus as a Libra Venus reflecting Leo light, this case, is not going to show up the same way if it was, oh, Taurus Venus reflecting Pisces light. Why? Because of the terrestrial factors. And this greatest elongation for Venus, as I said before, is going to show up in a different way, like in Berkeley, California, where I reside, than it would even in LA, some degrees further south of me. All right. Now, how can you find the moment of Venus's greatest elongation? Because sometimes it's 48 and sometimes 47, sometimes 46 degrees from the sun like this. Like, how do we know? And the answer is velocity. Slide, please. There we go. All right, so I'm bringing in at the top of the screen Venus maximum elongation, August 14, 2026 on Friday, Viernes, Venus's day. And you'll see here that the sun is at 2208 Leo and Venus is at 8 degrees Libra. Well, the key is looking at their speed, their travel. So, okay, on the right, and this is a table from Astro Gold software. I'm very grateful that they make this data available to us, and we should thank the people who they're getting the data from, right? So the Swiss ephemeris, thank you to the astronomers. But notice that the sun and Venus are moving at the same speed in the moment shown. So 57 minutes and 39 arc seconds per day, right? The sun is always about 1 degree per day, but as I shared before, orbits are ellipses, not circles, right? Earth is closest to the sun when the sun is in tropical Capricorn. We are furthest from the sun when the sun is in tropical Cancer. Right. So Capricorn, because Earth is closest, the sun's moving faster through Capricorn. It's really the Earth is moving faster when we're close to the sun. But in our earthly experience, it's the sun moving faster through our zodiac. When we're far from the sun, it's called aphelion. That's the sun in tropical Cancer. Then the Earth is moving slower in our orbit, which means we're moving the sun more slowly through our zodiac. Right. So this is like a slow sun time of the year, less than a degree per day, but it's about that, right? It's about 58 arc minutes. And of course, there's 60 minutes in a degree. Yes. Well, Venus can move much more quickly than the sun from our experience here on Earth, right? So this is all terrestrial experience. So Venus can get up to about 1.25 degrees. But when Venus is retrograde, and that's Venus passing between Earth and the sun. You can see like this is the direct motion. I don't know, from that star over there to that astrolabe over there, right? Direct. Let's check out how like, oh, apparently moving in the other direction, moving in the astrolabe to the star direction. You see that? That's like retrograde Venus passing us by. And we like to say about 40 days and 40 nights, Venus is retrograde. It's usually more like 42 days, right? As Venus passes us by. Well, before you hit it in reverse, which would be like negative travel, that's retrograde, you got to hit the brakes. You got to slow down, right? So you can shift from drive, direct travel to reverse, retrograde travel, right? In that moment of park in between drive and retrograde, that's the retrograde station, yeah? When Venus is at greatest elongation, her braking, her preparation for the retrograde, and I should just very importantly add, this is not Venus actually slowing in her orbit about the sun. She's just orbiting the sun. But our view of that orbit brings the experience of Venus direct and Venus retrograde, right? If we were like in the stands at the Great Chariot Race, you're at NASCAR and like drinking your Budweiser or whatever, right? Like it looks like the cars are going that way and then they're going that way, right? As they circle the track. But we're in one of the cars on Earth. Earth is a car, right? So Venus coming by us, she's not like direct half the time and retrograde the other half. And though she's just cruising around the track forward, we have this experience of going this way sometimes and going the other way at times, right? And in that experience, there's a time where Venus just appears to stop and then start moving retrograde. But as she's slowing to put it in park, to shift from drive to reverse, from direct to retrograde, there's a moment where Venus, who was like flying and moving through our zodiac much faster than the sun, equals the speed of the sun. All right. And that is the moment of greatest elongation. So if you have astrology software like this Astro Gold software, from which the chart is on the right of your screen and the table on the top left, usually you can find not only the longitude or zodiac degree of a planet's placement in that moment, which we show in the chart, but you can also see their travel. Generally speaking, because the sun moves about 1 degree per day, generally, you can just kind of find the time where from one day to the next, Venus has moved 1 degree, right? So here in this chart, she's at 8 degrees, the next day, 9. Like generally speaking, we want to be able to get more specific if we want to find that moment, okay? And again, in this cycle, that moment happens August 14th, 2026. If you're into that whole Gregorian trip, in a more elegant annual calendar, it's the sun at the 22nd degree of tropical Leo, Venus reflecting that Leo sunlight from 8 degrees of Libra, very close to a powerful, beautiful star called Porama, at the waist of the priestess constellation. All right, but that's a tale for another time. So let's move forward from this elongation. And what I want you to see is that from this point moving forward, the phase angle, the distance between Sun and Venus is going to decrease. Slide. But before we go there, let's see how this would be experienced with our feet on the ground here on Earth. And this, and I should have this up on the screen, but I don't. Wait, there's a way for me to do this. Stellarium.org, where you can find the amazing Stellarium astronomy software, this planetarium software. And it's free, which is incredible. I should say solar system scope, which we were looking for, you know, the heliocentric model. You can also play with that for free online at solarsystemscope.com, and you can pay a few bucks to download like a high def version. All right, so stellarium.org. I'm so grateful to these folks. I've learned so much about these workings through this gift of software. But most importantly, getting away from the small screen and having an actual experience in the big sky, the big screen. And that's the place where so many of my questions have formed. Like, hey, this should be like the most visible Venus. Why isn't it? Right? Okay. So here I have August 14th, 2026 at 3 p.m. in Berkeley, California. And it's almost that time right now. Now, sadly, the clouds came. We had some rain, which is actually great for the Earth right now. Not so great for Earthlings who want to see the sky like me. Because I will say this amazing truth that Venus at elongation like this offers an opportunity for us to see Venus during the daytime with the naked eye. I experienced this quite accidentally once. And by the way, tomorrow or the day after, you'll have a way shower because the moon is going to conjoin Venus Pacific time, and like in the middle of the night, Saturday becoming Sunday, like August 16th becoming the 17th, I believe. Maybe it's the 15th becoming the 16th. But when moon is next to Venus, right, and you go out in the day and you see that daytime moon, she's like, look here. So it's something if your skies are clear where you are right now and you're listening to this live, or at another time when Venus is at greatest elongation, I really encourage you to go have this amazing experience of Venus in the daytime sky. So I was at Joshua Tree, California once. I'll put this away and we'll just talk story for a second. And I was there to see a moon Venus conjunction. And like the one that's coming up, it was an evening star moon Venus conjunction, right? So I woke up in a tent in the morning and went outside, and there's the moon. And I was like, I'm going to see you with Venus tonight. And I was like, wait, I'm seeing you with Venus right now. Wait, what? And a friend came out and I'm like, hey, do you see that dot, that white dot there next to the moon? Yeah. Oh my God, we're seeing Venus during the day. I was stopping people on the trails that day. Like, hey, I know this is like kind of crazy, but can you see that dot next to the moon? Yes. And since then, like 4 times, and I've gotten like literally just like iPhone videos of elongated Venus visible in the daytime sky. Now, that's a big deal to me because I had been taught that was impossible. And the more like we need to learn the kind of framework and the general rules of these things. But then as we experience life and as we go out to the big screen and work with the heavens, it's like, wow, it's not like obeying these rules. Like, what's going on? But then we get to learn more rules. All right. So, and it's not just Venus's greatest elongation when Venus is brightest. Okay, now that's true for the moon, right? Like as the moon gets furthest from the sun, her smile grows until she's the full O, right? The full moon, right? It's like more moonlight, more moon reflecting sunlight to our eyes. Well, for Venus, there's 2 contributing factors, and I'm kind of getting ahead of myself because I imagine we'll stop here in the slides as well. Built these last month and so many things since, it's hard to remember. But there's 2 factors that contribute to Venus's visibility. One is the phase, like how much of Venus is reflecting sunlight to our eyes, and that's completely based upon how far from the sun. So maximum elongation, maximum Venus crescent. What's the other factor? Okay, so I encourage you, if you're watching this in live time, to get outside during the day, if the clouds allow, and experience daytime Venus. It's an amazing thing to do. And again, it's going to be easier to find Venus when the moon is with Venus, so the moon can show you where to look. All right. But it's going to be a lot easier to see this elongated evening star Venus in the evening time. So first thing we're going to do here is move through the hours and let the sun set. So now I'm August 14th, 26 at 9 p.m. And I have this set for Berkeley, California, where I reside. But by the way, Berkeley is at 38 degrees north of the equator. So is Athens, Greece. There's Seoul, South Korea, and many other places. Like I have the same sky experience as they do in Athens. I just experience it like 10 hours later or 14 hours before. We're going to face the west here because, of course, that's where we're going to see the evening stars. Let me go back. Here at 9 p.m., you can see the time in the lower right. The sun is like, I don't know, 5 degrees below the horizon. If there was a way in Stellarium for me to move from one day to the next easily, by keeping the sun like 3 to 5 degrees beneath the horizon, I would. Because of course, when the sun sets and starts sinking beneath, then the sky comes to light, right? I can't do that easily in Stellarium astronomy software, and I'm going to go through many days. And so what I can do is just going to the sun hitting the horizon, like the actual sunset. And on August 14th, 2026, here in Berkeley, California, that's happening at 20th hour at 8 p.m. And now it's hard to see anything because of the brightness of the sun at the horizon, right? But the software lets us play, lets me take the atmosphere away, all right? So I just want to offer, like, have that experience of the sunset in real life, go out, see Venus as an evening star. Of course, you're not going to remove the atmosphere of Earth. It's not going to look like what we're seeing on this screen, but this is going to help me in Stellarium astronomy software, show you some of the very important terrestrial factors of planetary visibility. Now, the Stellarium software is also allowing me to bring in the orbital path of Venus. Hopefully that's showing up on your screen. Again, if you're watching this at Instagram, head over to geminibrett.com/streams, and you'll get to see this full screen. And you'll see all my live presentations full screen over there. All right, so geminibrett.com/streams. In fact, we just hit the 1 hour mark. Sometimes that kicks me off the live stream at Instagram. All right, so geminibrett.com/streams. If you hear me, come on in. The water's nice. All right, there, hopefully you can see this green ellipse that showed up on the screen. I'll try to trace it with the mouse here. That's Venus's orbital path. But if I showed the orbital path of Mars, it's going to go just like the sun's path, which is here in yellow, the ecliptic, the heart of the zodiac. You know, we're going to be inside that circle. But because Venus and Mercury have their orbital paths between Earth's and the sun, we can see like their whole path here. And we're seeing the places of elongation, like I'm wiggling the mouse on one right now, right? This is where Venus's path is furthest from the sun in this direction, which is east of the sun, or in earlier zodiac signs or constellations, like the Twins constellation rises before the Lion. And then we see the extreme on the other side. You'll see Porrima, that star I was describing before, in the Priestess constellation. I use words like priestess to describe constellations and words like Libra to describe signs. You can even hear in Stellarium astronomy software, see the Libra glyph. Nowhere near the Scales constellation, because beautifully these astronomers, or whoever creates Stellarium, thank you, honors that what Libra is the equinox point, this place of the crossing of the equator, the plane of the day, and the ecliptic, the plane of the year. Now that's a long story for another time. Like in the astronomy class that I'm currently working on, Essential Astronomy for Astrologers, coming soon to a theater called you. Please be on my list, geminibrett.com. All right. Sorry for all the pitches, friends. Wait, no, I shouldn't apologize. You're here because you like the learning, and that's what I'm here to do. All right. So anyway, we see here Venus at this time is at the other extreme side of her ellipse, right? That's more full screen. And so that's Venus at maximum elongation, right? As she continues her orbit of the sun, then the sun and Venus will slowly get closer to one another, and then quite quickly so. So here we are, sun setting, Venus above the western horizon, evening star Venus. All right. And this will have a very different appearance in Los Angeles, in Mexico City, like wherever you are on Earth. It's a very similar experience from Berkeley, California, where I reside, in Athens, Greece, because as I explained before, we are at the same terrestrial latitude. So yes, very importantly, and I'm excited to share them with you here, there are significant terrestrial contributions to our celestial experience. And I'm not just talking about, you know, hills and trees or mountain peaks that are on your local topography, or the rain clouds or the marine layer or whatever that may be. I'm talking about the way the different signs rise and set. And again, I'll refer to a way that was described by the ancient astrologers, which is called the straight and crooked signs. And they're not talking about crooked like, you know, criminality or something like that. They're actually talking about the way the sign addresses the horizon. And we're going to have a view of that in kind of more extreme as I move through the slides here towards the Venus-Sun conjunction. And then, as I said before, we'll get back to this date of Venus's greatest elongation, and we'll go travel around the world a little bit thanks to Stellarium astronomy software. All right. So moving forward from here, we're getting to August 15th, 2026, which will be the time of the Moon Venus conjunction. They're pretty close here. It's going to make me wish not only that the clouds are gone, but even if they are, that I was like in Hawaii because Moon and Venus together will set before their conjunction in this particular meeting, whereas places who live further west of me will still have Venus up above the ground when the Moon comes to meet Venus. But I'll go out and see this, bring Maya, bring our baby to go see this. We'll have some kind of ceremony. In the shamanic astrology paradigm, in Daniel Jamario's astrology paradigm, this is what we call the crown gate of Inanna's ascent. And that's a whole wonderful, beautiful ceremony. But Anna and I talked about how I think we're going to have a ceremony where I crown her. And so, yeah, we'll see how we can do that. I'll probably try to get her up in an exalted place, put a crown on her head. Cool. What will you do? That's how we will choose to align. All right. And as I shared before, the Moon Venus conjunctions are not only so beautiful to see, but the Moon will help you in the daytime sky meet Venus when she's visible there. All right. Well, we're zooming in a little bit because we're going to watch this dance as we move through the days. We're already the day after Venus's greatest elongation. Right? So how many degrees in the zodiac is Venus from the sun? Now I think could easily conclude, and this is the way it's typically taught, that the greater the Venus phase, right? So the further Venus is from the sun in the zodiac, the higher Venus is going to be above the ground, the greatest altitude Venus will have at sunset. Well, we're going to see that that is not necessarily true. And this really has to do with terrestrial factors, or let's say terrestrial and celestial factors, marriage of heaven and earth. Now, Venus and sun in the zodiac, that's also a celestial experience from the earth. There's like that is a terrestrial thing too. All right. But I mean like where you are on Earth's surface. So in Stellarium, I have to highlight the sun here. You can see like the red rays coming off the sun. You can see that it says sun in the upper left. Those are clues as to that truth. I have to do that for me to just like go from one sunset to the next. I wish I could highlight Venus for you. I just did. Keep your eyes on Venus, who currently is embraced by this blue star on the screen, okay? As we move through the days. So we're August 20th, 22nd, 3rd, 4th, 5th, just clicking through the days. And here you do indeed see Venus getting lower to the ground as the phase angle decreases. We'll do this also, however, from like, let's go as far south of the equator as I am north. So Melbourne, Australia is a good example of this. They're 38 degrees south of the Earth's equator, and I'm 38 degrees north here in Berkeley, California, or you would be if you're in Athens, Greece. And we're going to see Venus take a very different shape. I'm told one of the names that the Maya people attributed to Venus was the wasp. And it has to do with these beautiful shapes that Venus makes, like night after night as an evening star, or morning after morning as a morning star. And there's 5 different like beautiful kind of dances that the wasp Venus does. All right, well, back to the chart. Here's the day of Venus elongation again. So on the right, you can see the phase angle decreasing from this 46 degrees at maximum elongation this particular cycle. But I really want you to focus in on the left. Again, know that like the sun here in the red slice, that's Leo, Venus in the yellow slice, that's Libra. We're actually going to get to see Venus retrograde here and see how much Earth is contributing to the retrograde of Venus, because Earth's zodiac moves with us. So let's just move forward. There's Venus moving forward into greater degrees of Libra, but at this time, the sun is moving faster than Venus, so closing that gap. Here's Venus, as you can see, moving from Libra into Scorpio. Just happened. But as Venus begins to pass Earth by, we're going to see Venus move from Scorpio retrograde back to the Libra sign. Now I'm stopping at this time, and I can just see as I look to the chart that Venus is about 40 degrees from the sun, the ninth of the zodiac, the novile. It's about that time in the Venus cycle, whether she's on the evening star side just before the retrograde or on the morning star side after station direct, when Venus is at maximum visibility. I offered you the pop quiz question before of why would Venus maximum brightness not be the same time as Venus maximum phase angle, right? Because more reflection of the sun should be brighter, right? Just like the moon. For Venus, it's not true because there's another really significant factor at hand, and you can see it on the screen. It's Venus's proximity, right? Again, Venus is brighter than Jupiter because of her albedo, for one, like her composition, her color, the gases that her atmosphere is made of, how she reflects sunlight. But mostly because Venus is closest to Earth, right? Venus, our neighbor towards the inside, and Mars, our neighbor towards the outside, where Jupiter is so much further away. So gigantic, but far. Just like the sun appears to be the same size as the moon in our sky, the sun is super gigantic, but way further away, right, than moon. Well, Venus is brighter than Jupiter because so close to Earth. And so Venus's brightness has two significant contributing factors. Others I'm sure I'm not aware of, but the two that I know are Venus's phase angle, how far from the sun. And in this cycle, we saw she got 46 degrees away. So how much crescent on Venus do we see reflecting sunlight to our eyes? And Venus's proximity. And there's this interesting balance between those two factors that helps us find the time of greatest visibility. Now, I don't know how to do that in an astrology chart. Like I shared before, to find the greatest elongation, we find the moment where Venus's speed equals the speed of the sun. They don't have a button for that in the software that I use. I might actually ask them to put one in because I could then easily click to Venus or Mercury's maximum elongation. And just to retrograde back to this truth, like for the moon's greatest elongation, I just write moon opposite sun. Or for Jupiter's greatest elongation, sun opposite Jupiter. Like they can get opposite the sun in our zodiac, but Mercury and Venus can't. For Mercury or Venus's greatest elongations, either as an evening star or later after the retrograde as a morning star, I need to find the moment that those planets' speed through the zodiac is equivalent to that of the sun. But there's no button for greatest brightness. So in Stellarium, I kind of can look at the magnitude, the brightness. But like, it should be the kind of like they'd show me the same number for like 5 days. So I've generally found by looking at the reports of this is the date of greatest brightness or whatever, that it's the times either before station retrograde or after station direct when Venus is novile or 1/9 of the zodiac, about 40 degrees from the sun. So you can see here, like that's not true. It's like 39 and 2/3 degrees away, but it's usually about 40 degrees. This September 18th just came from people who know more than me. And thank you to the astronomers who give us some of these codes. All right, so continuing on from here, Venus, you can see in the chart really slowing down. Hopefully you can see in the left like why that is. And this date, October 3rd, 2026, is in this particular cycle, the date of Venus retrograde. And you can see that indicated in the chart on the right because the font for Venus's longitude or zodiac degree just went red. Okay, so that's how I have the Astro Gold set up to display retrograde. So red font, Venus at 8.5 degrees, tropical Scorpio, now retrograde. Much harder to see that in the left, in the heliocentric, sun-centered model of the solar system, right? Like I couldn't tell you the exact date of it from that point of view. But I can see in the left why Venus appears, or no, not appears to, why Venus moves backwards through our sky. I want to interrupt myself. Like people always tell you, oh, this is this optical illusion. And sure it is. Like the highway experience where a car seems to be moving backwards as you pass it, though you know they're moving forward. Like that's why Mars or Jupiter or Saturn, the outer planets, go retrograde. Mercury and Venus go retrograde for a different reason than I was describing before. You know, this is direct motion and that's retrograde. So passing us by. Importantly, whether an inner planet, Mercury and Venus, or the outers, the retrograde period is that time when that planet is closest to the Earth. So that's something to consider, right? Proximity. Now in the chart, you'll see that at this time, Venus is about 28 degrees away from the sun. Generally speaking, I'll just share that Venus stations retrograde and that later stations direct when about a sign away. So it's about 30 degrees away. Usually it's more like this 28, 29 zone. But I just remember 40 for greatest brightness and 30 for station retrograde or direct. If those are new to you, you're welcome. And thank you for the present of your presence. All right, let's move forward from here after we just draw some arrows in space. Again, that's the direct motion, like sun from Virgo to Libra. This would be the retrograde motion, like Venus from Earth Scorpio to Earth Libra, right? So again, this is happening not only because of Venus's orbit, but because of Earth's. And here we're seeing Venus in Scorpio still, now 10 degrees from the sun. Now on the right in the chart, what I've done is I've brought in the 30 degrees of the sun's beams. What? Well, in Hellenistic astrology, it is said that when a planet is within 15 degrees of the sun, so either on the evening star side or the morning star side, they are under the beams of the sun and therefore they can't be seen, right? We're blinded to them because they're so close to the light. Now, interestingly, if you see that that's 15 degrees that follows the sun after sunset, or 15 degrees that precedes the sun to the eastern horizon before sunrise, that's a sign's worth of sky. Is this why signs are 30 degrees? Because the beams are 15 to one side and 15 to the other, signs worth of sky? That's like an interesting thing to consider. I think the 12-ish lunations a year is probably more the reason of why 12, but it's in the human body and in so many other places. I like to share 12ness first and foremost through the sacred geometry and harmony. Tales for another time. Now for Venus, 15 degrees is not the right rule. Venus is just too bright. So a better rule, now shown on the chart, is like 10 degrees away. And this is something I learned from Daniel Gemario, my first teacher, who taught me so much about synodic cycles. Again, if you weren't here earlier, I'm currently co-creating the synodic cycles course for Daniel's Turning of the Ages Mystery School. It's taken some time because Daniel's in the Philippines and the time zones and me being a father of a young one and yada, 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 but it's moving along. And these are slides that I updated for that course. All right, so now I have like 10 degrees of beams. And here you can see Venus is just outside of them, right? Sun at 24-25 Libra, Venus at 4-27 Scorpio, just a little bit more than 10. And because Venus is retrograde and because the sun never, ever can be, right? This would be the time of Venus setting into the beams of the sun, or the sun overcoming Venus in another way we could see that. Well, so how does this look on Earth? We're here on October 3rd, 2026. So this is the time of Venus station retrograde. Now, one very important celestial factor is pretty evident on this expression, thanks to Stellarium astronomy software that you see on your screen. The sun's path is shown in yellow. Okay, that is the ecliptic. Of course, really what the ecliptic is the path that we here on Earth describe as we orbit the light. Yes? But from our point of view, we experience that annual motion as the sun moving through us, moving through the signs, moving through the constellations of the zodiac, right? And generally speaking, the solar system is relatively flat, but every planet has its own path. Like where that planet's path crosses the sun's path from our point of view, those are the planetary nodes, right? Like the moon every month snakes above and below the path of the sun, right? Well, every planet has its own crossing points, all right? So generally speaking, we can say the planets are like on the ecliptic plane, but they're not. They go north of and south of. And in this moment shown, October 3rd, 2026, when Venus is stationing retrograde, notice that Venus is so much closer to the ground than the degrees of the ecliptic that she projects to. Okay, so when we place a planet in a degree, what we're doing, or a star, let's say like Arcturus up here that I'm circling like well above the sun in this view. Arcturus in our day and age projects to like 24 tropical Libra. Okay, it's like the same place of the heavens, the same degrees as Spica or Spica or Chitra, the shaft of wheat that the priestess of the heavens holds. Okay, like so how the heck do we say these two stars are conjunct? They're like 30 degrees away in what is called celestial latitude, meaning how far north or south of the sun's path. All right. And latitude obviously matters. It's not like New York City is conjunct Machu Picchu, but there's the same longitude. And that also matters, right? So just know that like when we say Venus in this case is in, you know, what, 8 degrees Scorpio, I think it was, we're taking a perpendicular line and we're drawing from Venus's body up to that place on the sun's path, on the ecliptic plane, on the heart of the zodiac, okay? So the chart can't really show us that in this case, Venus is like extremely south of the sun's path. Well, in the northern hemisphere sky, south means less visibility. I think you can see here, and you're going to, that Venus would set well before the degree that Venus projects to. Northern latitude, so planets or stars north of the ecliptic plane, like consider Spica and Arcturus here. Spica is this one that I'm circling close to the ecliptic, Arcturus so far away. Like Spica is going to set and Arcturus is going to be way up above the ground. Okay, we'll flip this thing around, which is the southern hemisphere view, and the opposite is true. In the southern hemisphere, southern latitude offers greater visibility. And again, at the end of this, we're going to take a tour. We're going to go to a few different places. We'll see how that's true. And one of the places I'm offering this teaching is for a Mercury class, okay? But again, if we start with Venus, because she's so much more visible and she gets further from the sun and the like, it's just easier to experience these teachings. But it takes 19 months. And it really takes 8 years or 5 cycles with Venus and the sun, 5 times this 19-month period. Where for Mercury, the cycles are every 4 months. So Mercury is like master class in some ways, observationally speaking, but also faster class. I love things that rhyme. All right, let's move on from here. So this is Venus station retrograde. And we're just ticking through the days, one sunset to the next. And we're going to go to this point. This is October 17th, 26. And this is Venus now 10 degrees from the sun. So we'd say this is like Venus disappearing into the light. But from the northern hemisphere point of view, in this particular cycle, 10 degrees is not right. It's not nearly enough, nor is it from the southern hemisphere point of view, where they're going to have much greater visibility of Venus than the 10-degree rule would suggest, and much less here in the northern hemisphere for this particular, what we call heliacal setting of Venus, Venus going into the fires of the sun, okay? And one of the important reasons, which you can see in the screen, is that's latitude, that Venus is south of the sun's path, like pretty extremely so. Venus can get 8.5 degrees away from the path of the sun, something I didn't know for a long time in my study. And I was forced to know because I saw Venus once when she was only a degree away from the sun in the zodiac. And I was like, what? That's not possible. Well, it turns out latitude really matters, and that's not it. So we really need to explore the power of the straight and crooked signs. I think I will just continue on from here to at least show you this. On the right is this moment in time where the sun and Venus, evening star Venus, are separated by 10 degrees. You can see that in each of these frames, we are looking west. In the right, it's the view from Berkeley, California. In the left, it's the view from Buenos Aires, Argentina, like southern hemisphere, right? So there's two reasons why in Buenos Aires at this time, Venus will be quite visible after sunset. One is that latitude factor, that again, southern latitude, so a planet or a star south of the sun's path means less visibility, either as morning star or as evening star in the northern hemisphere. But southern latitude means greater visibility for southern hemisphere observers. So terrestrial contributions to our experience of the celestial. Yes? But the other thing I want you to notice here is that in the picture on the right, the northern hemisphere picture, do you see how the ecliptic, so the yellow, that's the path of the sun, the heart of the zodiac, do you see how like slanted it is? Whereas the picture on the left, it's rather straight. So why is that? All right. And we are going to explore this in a different way. And I think we will start at least today on August 14th. Just checking in with questions like Shauna asked. So from our point of view, when Venus is separating from sun, is there a time she moves faster than the sun? Absolutely. Venus, for most of her orbit, is faster than the sun. So the greatest elongations between the time of greatest elongation evening star, then station retrograde, station direct after the Venus-Sun conjunction, station direct, greatest elongation is a morning star. Between that greatest elongation morning star and evening star, Venus is moving faster than the sun. And the fastest is, we can't see it, but when Venus is conjunct the sun, we trust the math, trust the tables, it makes sense, right? So Venus behind the sun, the direct Venus-Sun conjunction, the exterior conjunction, or they say superior conjunction, that's the fastest Venus. Janice says, this is amazing. Thank you. Thank you for your reception and your reflection. I greatly appreciate that. Let me just see in this other space if there's other questions. All right, cool. We're good to proceed. All right, so let me share my screen in this way. And you'll see a Brett inside a Brett inside a Brett inside a Brett. Let me, how do I guess just this. And you know what? Let's just test this and make sure it's working. Will you please let me know that you can see both this chart, maybe my circle thing, and also this tree with the School of Astrology logo nearby? Are you able to see all of those things? And can you see now that I've gone to Stellarium astronomy software here and I'm like circling Venus? So you can just write yes, and that will mean yes to all of those things. So somebody who's here live, please write yes, and I'll know I can move on. Sue, thank you so much. All right, cool. Ellie, thank you. Great. Well, let's get this stuff back on the screen. I meant to hit record at the beginning, but I'm going to hit record now. So it'll be a really weird time to announce this again. Ah, it is recording. Thank you, StreamYard. All right, cool. How do we get this all on the screen? Okay, cool. So Venus maximum evening star. It's hard for me to get the exact moment because I can go like minutes before and after and find that Venus's speed at 57 minutes and 39 seconds is the same as the sun's. But I just put Venus in this case exactly at 8 degrees tropical Libra. And hey, we should see that she's looking at Neptune across the way and applying to Saturn and in this beautiful sextile with Mercury and Jupiter and the like. And there's a square with Mars, kind of, this trine with Uranus, the grand air trine with Pluto, and astrology. But I'm here to talk about the measurable, the astronomy side, and why this greatest elongation, again, has a very different expression depending on where on the Earth we are looking from. Okay, so here's Stellarium astrology software, and it looks like it's like current time. I see the clock ticking. And so I'm in Berkeley. We're going to move and let the sun set over here. Bam, and then I'm going to stop time. Okay. And you know what I think what I'll do? Well, first let me just say this. So this would be more like a human experience, right? And then I have to put my head back to look up, right? And then turn my head to look left, right? But the software lets us play, even in this case, letting us see beneath the ground. So I'm going to zoom out here, and now we're looking at east and west at the same time. Soundtracked by Dog Drinking Water. Thank you, Isabel. And this blue curve here, this is the equator, all right? Now, the equator is like at a different altitude depending on where on Earth you're looking from. That's like part of the puzzle. It's a very important thing. I can't teach you all of astronomy right now, though I would love to teach you everything I know. But importantly, the equator is always due east and due west. It's perpendicular to the north-south rotational axis of the Earth. The ecliptic, the sun's path, is not. The only parts of the ecliptic that rise due east and set due west are the equinox points, because they're the only points on the ecliptic or the plane of the year that are on the equator, right? So between Libras, like Scorpio, Sagittarius, Capricorn, Aquarius, Pisces, like those are signs that are south of the equator. And we're going to later see signs that are north of the equator. Well, let me just do that now. I'm going to rewind time like 12 hours from here. Okay, let's go here. So this is 0 Libra rising. And thanks to Stellarium astronomy software for like using the Libra glyph, the Cancer glyph, the Aries glyph, and we'll see the Capricorn glyph in a bit. All right. Well, again, the equinox points, they are where the sun's path or the annular course, right? Annual course intersects the plane of the day. The equator is the plane of our rotation. The ecliptic is the plane of our annual orbit, our revolution. All right. And so there's the equinox points. Well, just consider that when 0 Libra is rising, 0 Cancer is at the midheaven. Hopefully that's making sense to everyone. Please comment if it doesn't, and I'll check in with the comments in a bit. So when 0 Libra is rising, of course, 0 Aries, the opposite degree, is setting. And 0 Cancer is up at the midheaven. So let me just give you some definitions of ascendant, descendant, and midheaven, okay? Ascendant is where the ecliptic, or the heart of the zodiac, the sun's path, intersects the eastern horizon. The descendant is where the sun's path intersects the western horizon, all right? The midheaven is where the sun's path, the heart of the zodiac, the ecliptic plane, the degrees, intersects the meridian above ground. Well, what's the meridian? It simply separates the eastern sky that goes up from the western sky that goes down, right? And then we have these quadrants. We have above the ground going up. We have above the ground, below the ground coming up, above the ground going up, above the ground coming down, below the ground going down, right? That's the whole idea about quadrants in between the astrological angles, the ascendant, the midheaven, the descendant, and the IC, all right? Well, when we look at a chart, the midheaven is just like, depending on the house system you use, it's either the top of the circle in the 10th house, right? Or it's somewhere up near the top of the sky if you're looking at whole sign houses, for example. You can't tell that some midheaven degrees are way higher than others and some are way lower, right? Like we just see a circle in the chart wheel, and the chart wheel is amazing. It's like incredible. It's so beautiful. It has so much to share. It's a great model for our Earth experience of the sky and what's happening in the heavens. But it is also a very limited model. So for example, like here's Virgo at the midheaven. Let's move forward in time, and I'll just go by hours. And we're going to see that the midheaven degree is moving from Virgo to Libra to Scorpio to Sagittarius to Capricorn. And I mean, you're seeing like it pointing in a different direction in this quadrant, this Placidus house system I'm using here. But like, we don't see what that means. We don't see that it's like higher or lower. Like you have to like learn the astronomy. And again, for me, it's like I've just been outside. It's like, wait, why is like what's happening here? Okay, because importantly, like let's say this is the zodiac. Like every day there's the highest point at the midheaven, and then 12 hours later, the lowest point. Okay, and it's actually doing something like this, which is so amazing because the ascendant descendant axis are ruddering against the cardinal directions, which is why one of the ancient names for the ascendant oiax, the rudder. All right, it's like this. But importantly, we just talk about the altitude of the midheaven. Like this is happening every day. Well, what's the highest degree? In the northern hemisphere, in the temperate northern hemisphere, that is 0 Cancer. And when is 0 Cancer at the midheaven? When 0 Libra is rising. Ellie, will you tell me where I'm pinching right here? Does that seem to be on the left of your screen? Like where we draw the ascendant in a chart? I think that's true, but it's hard for me to tell here. Right, so when 0, thank you. When 0 Libra is rising, 0 Aries is setting. And that means 0 Cancer is here. Well, 0 Cancer, and I'm talking tropical zodiac, the Earth zodiac, that's the highest degree in the northern hemisphere. That's why when the sun is there, it's the longest day and the shortest night. But in the southern hemisphere, that's the lowest degree. Let's stick with the northern hemisphere for now. What's the lowest degree of the zodiac for the northern hemisphere experience? Let's say the temperate northern hemisphere. In Berkeley, California, where I am, what is the lowest degree of the zodiac? What is the degree of the zodiac that's closest to the ground? And the answer is 0 Capricorn. Okay, well, when is 0 Capricorn at the midheaven? And the answer is when 0 Aries is rising. So let's look at this thing like this and say this is the ascendant degree. If it's 0 Libra, here's 0 Cancer, and we're talking northern hemisphere. Do you see how straight the ascendant is? Like this is the ground, okay? But if what's rising is 0 Aries, now we have 0 Capricorn, the degree that's closest to the ground. So do you see how crooked the ecliptic is to the horizon? This, even more than celestial latitude, is I would suggest, the most important terrestrial contributor to morning and evening star visibility. There's three things that we've already looked at. Phase angle. Okay, let's say this is Venus. Let's say Mercury. Let's say this is Mercury here at the top of my finger, and then the sun currently is at my palm. All right. And let's say this is Mercury rising, and we get Mercury, 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 and then the sun rises and no Mercury for you, right? Well, if Mercury is that far elongated from the sun, in a sign that rises straight, you see how you get a lot of Mercury. But if he's that same elongation from the sun, in a sign that rises, quote unquote, crooked, they're still rising, even though so far from the sun in the zodiac, they're rising at like the same time. So this matters so much. It's like everything. And by the way, the angle of the ascent also determines the length of the ascent. People will teach you that every sign rises in 2 hours. They're like 12 signs, 24 hours, 2 hours per sign. On average, well, I lived in Seattle. It's 48 degrees north of the equator. Aries and Pisces, because they rise like this, they rise in like 45 minutes each. Virgo and Libra rise, it's like more than 3 hours, almost 4. This is a great contributor. So we have these three factors: elongation, phase angle, how far from the sun. 2, north or south of the sun's path. And again, in the northern hemisphere, north, greater visibility, south, lesser visibility. 3, are they in a straight or crooked sign? Now, there's an additional confusion here. All right. So generally speaking, you just want to consider what's the highest degree of the zodiac. Okay, well, now this is going to cause one more maybe issue, because you likely have been taught that the midheaven is directly above your head. Okay, I'm going to get to this point. Just because I said this before, astrology honors Libra as a home for Venus in our tradition. The sun as a home for Leo in our tradition. Modern astrology often describes Leo as the 5th and Libra as the 7th, as if the Earth doesn't spin. And I will say globally, the terrestrial signs are the Earth's houses, so I get that. So many modern astrologers associate the 7th house with Venus and the 5th house with the sun. So it's pretty cool that at this time, let me even move through the minutes and see if I can get a Leo cusp here before Venus sets. I can't. Anyway, that at this time, I'll just go to an equal house system and it'll work. We're getting Venus at the 7th in Libra and the sun in Leo in the 5th. So that's cool. Well, traditionally the sun has nothing to do with the 5th. Look, why would the sun want nighttime? This is the ground. The sun beneath the ground means night, right? Traditionally, Venus rejoices in the 5th. Why? It's 10 p.m. Like, what are you doing at 10 p.m.? Especially maybe when you were younger it's Venus time, right? Generally speaking, kind of 8 to 10 p.m., but clock time's nonsense. All right. Let me go back an hour. We'll do like 9 p.m. And we see this Libra Venus well above the horizon, reflecting Leo light. And she's at her elongation, that 46 degrees that we saw before. This should be Venus highest above the ground. So I'm looking at a factor called Venus's altitude, right? In this case, the sun is 11 degrees beneath the ground and Venus is about 10 degrees above. All right, well, stellarium is going to help us see this in like a more beautifully illustrated way. I'm going to go to 9 p.m. So sun setting and Venus rising. Venus as evening star still above the ground after sunset, right? So we get this beautiful view of Venus. And because she's elongated in some senses, doesn't this mean like most time with Venus after sunset? And the answer is not necessarily. In this case, let me take like the supersize away. Venus is rather close to the ecliptic plane. Her latitude is only 1.5 not even degrees south of the ecliptic. Okay. So in this case, her like celestial latitude, the fact that she's south of the sun's path isn't as great of a contributor as it would be if Venus was like down here. We saw that later in this particular cycle. Okay. But we are in a place where the setting sign and the rising sign on the other side is a kind of a rather crooked part of the ecliptic. It's late degrees Sagittarius at the midheaven. And the midheaven, it's going to be a lot easier to show that at a different time of the day, is not the highest part of the ecliptic. You will be taught by astronomically ignorant astrologers that the midheaven is above your head. Look how far it is from the zenith in this case. No, it's simply where the sun's path intersects the meridian. It is the degree that is shifting from going up to coming down. It is culminating. It is reaching its height. It is crucial, okay? Not only is it not the point that's above your head, it's not even typically the highest part of the zodiac. That's especially true, by the way, when a solstice degree is rising like this, right? Early Capricorn's on the rise. As you can see, like the highest part's over here. Okay, it's always in the 10th whole sign. It is always the cusp of the 10th equal sign. Okay, so for example, if 3 degrees Capricorn's rising, then the highest part of the chart in that moment of the sun's path of the ecliptic of the zodiac is 3 degrees Libra. Okay, if, and you can see the ruddering here, if we have, I don't know, this is like 21 degrees Aquarius rising, I know because I know my stars. All right. So if 21 degrees Aquarius rising, then 21 degrees Scorpio is up high, even though at this point, that's the heart of the Scorpion constellation, 10 degrees tropical Sagittarius, culminating at the midheaven. So Sagittarius midheaven with this Aquarius ascendant. But Scorpio, because it's what squares Aquarius, is the highest point, okay? So for us to get from a chart to this idea of straight and crooked, which is the greatest contributor to visibility, you simply have to know your squares. All right, so like if I look to this chart and I see, oh, well, we have Virgo setting, then the square is Sagittarius. Now I have set this set up as an equal sign, okay? The equal cusp of the 10th, which is not the midheaven. I'll put the midheaven on the screen while we're here. You know, in this case, they're close because we're close to an equinox point rising. But let me go back some hours, and now the midheaven's in a different sign than the 10th whole sign, Libra for Capricorn, or the equal cusp, which is the non-adjustable. It just means 90 degrees away at the highest part or the lowest part of the ecliptic, above and below the ground, okay? So when you're considering like the altitude of the ecliptic, this whole thing, just take either what's rising or setting and see what's exactly halfway in between, right? So if Libra is setting, Aries is rising, and Capricorn's at the top. Well, in this northern hemisphere, that means low, because Capricorn's the lowest sign. Sagittarius and on the way to the Tropic of Capricorn, and Capricorn on the way back from the Tropic of Capricorn, that's the lowest point. 0 Capricorn, the south point, lowest, because south is far from the northern hemisphere. Okay, well, in the southern hemisphere, it's close, right? So in the southern hemisphere, when 0 Aries is rising, you get this thing. So this can help me say, like, okay, well, where on earth should I be for the greatest experience of this visibility? But maybe, you know, think globally, but act locally. In my own experience, how visible is it? Right? So in this case, because Venus is in Libra, that means I see, you know, Capricorn on high at Venus setting time, and it's not nearly the visible experience in this particular elongation as it would be in the southern hemisphere. By the way, the greatest visibility is, interestingly for us, in the northern hemisphere when Venus is elongated in Taurus. Why? Because Venus elongated in Taurus, and especially like kind of mid-Taurus, means that the sun is at the Aries equinox. Or let's even do this. Let's put the sun at 27 Pisces. In the tradition, that's the degree of Venus's exaltation. And I think this might have to be about the sun being at that degree, because in the northern hemisphere experience, if the sun's at like 27 Pisces and Venus is elongated as an evening star in Taurus, where she's said in the tradition to be at home, consider this, right? Like when 0 Aries is setting, 0 Libra is rising, 0 Cancer is here. If 0 Aries is setting and the sun's at 27 Pisces, then the sun is beneath the ground, night is just beginning, and we can see that Taurus Venus crazy super high. That cycle is going to come, but I want to finish by talking about this one. I only have a few minutes left. Thank you for spending so much time with me here. Let's take a little trip around the world. And as I said before, let's just move, I think, from 38 north of the equator to 38 south. So I'm going to relocate this to Melbourne, Australia. Now, I want you to see that in the chart, let's go to like 8 p.m. I mean, springtime there, so the sun will be setting later. Let's go to 9 p.m. In the chart, it doesn't really look that different, right? It's like Aries rising, Capricorn. Like, I don't get to see that this is crazy high in Melbourne and crazy low in Berkeley. But let's go over here in Stellarium. Let's do this sunset time on August 14th with Venus at elongation in Melbourne, Australia. Now, maybe I should have chosen somewhere closer to my own time zone in the Southern Hemisphere. You know, let's do that. Let's go to like Buenos Aires in Argentina. All right, so I'm going to relocate us to Argentina. And then we'll go also to like 9 p.m. and see how straight that setting is. Okay, now importantly, in the Southern Hemisphere experience, the midheaven's in the north, where in the Northern Hemisphere experience, it's in the south. All right, and that's an intriguing thing too. But this is why in the Southern Hemisphere, like I can bring the sun much closer to the horizon. This is an amazingly visible Venus. And then there's going to be a place on Earth where not only is this descendant so straight, and again, where is that? It's where whatever is square this degree that is setting is directly above our head, right? Not only will it be, you know, so straight, it will literally be vertical. Okay, so let's play that game. You know, where is the sun right now? We saw it's at like 22 Scorpio. But I'm kind of interested in like, well, what degrees here? Because I want the sun to be down beneath the ground a little bit, right? So the stars are coming out. And the answer is, I don't know. I'm looking at Regulus in our day and age. The heart of the lion, Regulus, just moved into the first degree of tropical Virgo. All right. So let's say like 3 Virgo. Okay. We'll put like 3 Virgo at the descendant. You know, something like this. And you know what, let me just, because it is 30, I am going to cast this chart in Melbourne. So we're looking at like 6 p.m. August 15th, 26 in Melbourne, Australia. Okay. And maybe we need to go through the minutes a little bit more so the sun gets a little further down. Yeah, here's this like 3 Virgo zone. I think it was like 6:33 p.m. on the chart. Something like this, okay? Well, again, like a super straight descendant. And again, because in the Southern Hemisphere, 0 Capricorn, the most southern sign, or like now we're into Virgo setting. So we're talking Sagittarius, right? Still super south. It's high in the sky, right? Because that Tropic of Capricorn, like Melbourne's a lot closer to the Tropic of Capricorn than Berkeley, California is, right? All right, so let's use this like 3 Virgo setting. So then the question is, there is a place on Earth where 3 Sagittarius is directly overhead. And the easy way for me to get there is to just put this midheaven at 3 Sagittarius. So let's say here, and then I can ask Astro Gold to show me what the declination of that degree is. And the answer is 20 south 45. All right. Well, I was looking at this yesterday, and I know Asuncion, Paraguay is rather close. No, it's at 25 south. Where did I end up? That alarm you just heard is a reading that I have. And by the way, that's my job. So if you want to support the work and help me feed my baby, you can book a reading, GeminiBrett.com. I'm actually currently offering an eclipse special. You can get to the shadowy hidden menu at my site, GeminiBrett.com/shadow. I'm going to put that up just while I try to find this work that I did yesterday. All right, now we'll just do it together. Okay, so we're going to go on Earth, and we're going to find where on Earth is, let me push this button again, is like 20 degrees south, all right? And we should probably do this on Google Earth, but I don't have the time. Anyway, I was looking yesterday, and somewhere here in like Bolivia, I thought I'd come to Paraguay, but let's try like Campo Grande in Brazil. Okay. Do they show the latitude and longitude here? I don't know. We'll just go in Stellarium, and I will ask to see if they know about Campo Grande. Fortunately, they do. We'll let them know that's in Brazil. And there we go. We're at 20.5 degrees south. Okay. Well, the important truth is that 20.5 degrees south of the equator is a place where degrees that of the zodiac that are 20.5 declination, they are directly overhead. Okay, so we're going to relocate this now to Campo Grande. Oops. Brazil. 20.5 south. I'm going to go to sunset. That's not going to work. Let's just do this. And I'm going to put like 3 Virgo at the descendant. So it's like here, okay, 6:09 p.m. Let's do that. No. All right, yeah, look at how at this time, the descendant, the ecliptic, is just perfectly vertical to the horizon. Right? Why? Because the nonagesimal, or the equal sign 10th, is at the zenith. I mean, almost exactly. So in other words, this is a place that not only has like the straight sign rising, but it's absolutely vertical, because in the tropics, which Campo Grande is, we do have 2 degrees of the zodiac that do culminate directly overhead. When the sun is there, it's a day without shadows. So I just did this last part of our journey kind of too quickly, but you have it recorded. Hopefully you can take some time to review this. And hopefully it is just clearly illustrating, because pictures tell 1,000 words and animations a million, why this terrestrial matter of straight and crooked signs is like the greatest of these factors. Well, no, it's not. Elongation from the sun, but not every elongation should be treated equal, because depending where you are on Earth, that elongation might spend tons of time after sunset in the sky or very little, depending on distance from the sun's path, that's celestial latitude, and also how straight or crooked that degree that is setting is from the experience of your local place on Earth. All right. Hopefully that added a bunch of fascinating, strange things. Sue, I appreciate your reception and your reflection. GeminiBrett.com if you want to support the work. You know what? Let me make sure this GeminiBrett.com/shadow functions. And yeah, it does. So if you want to book an eclipse special with me here in shadow late season, come on by GeminiBrett.com/shadow, and I will look forward to seeing you and tuning into your chart with you when stars align. But thank you so much. The present of your presence is the greatest gift. See you in space, friends.